Today we will see about the design of flanged beam or T-beam. Myself, Dr. Sahay Ruban, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. So, T-beams are formed when a reinforced concrete floor slabs, roofs and decks are cast monolithically with their supporting beams. Generally, formwork are placed for the bottom and side of the beam and soffit of the slab. Bender bars and stirrups of the beams are extended up to the slab. After that, all the elements are cast at once from the lowest point of the beam to the top of the slab. This is about the T-beam. Let us see the design procedure based on IS 456-2000 codal provision. Okay, let us see some of the notation used for T-beam section. This is B, that is actual width of the flange. This is effective width of the flange. Without the web is given by BW, this is without the web, and depth of the flange is given by DF. Neutral axis is normally called as NA. Let us C1 is equal to, that is compression is equal to 0.36 FCK BW into XC max, and C2 is equal to 0.45 FCK into BF minus BW into YF. And then tension force is equal to 0.87 Fy into AST. Then these are the notation as well as forces in compression as well as tension. Let us see the design procedure. This is clearly given in page number 96 of Annexure G 2.1, 2.2 and 2.3. Let us see one by one. Case 1, when the neutral axis lies within the flange, that is XU less than DF. Consider this is a rectangular B. Okay, so B is equal to BF, and you have to find out the value of XU, that is 0.87 Fy AST divided by 0.36 BF into FCK. If XU is less than XU max, you have to design the section as a under reinforced section. So already we know MU is equal to 0.87 Fy AST into D, 1 minus AST Fy divided by FCK BF into D. In case the section is over reinforced section, that is XU greater than XU max, you have to use this formula to find out the value of moment of resistance, that is MU is equal to 0.36 FCK into XC max into BF into D minus 0.42 into XC max. This is case 1, when the neutral axis lies within the flange. Case 2, when the neutral axis lies outside the flange. So like if the neutral axis lies outside the flange, these are the condition when XU is greater than DF and DF by D is less than 0.2 and DF by D is less than 0.43. The moment of resistance is given by page number 96 of IS 456 G 2.2, that is moment of resistance. You have to calculate MU is equal to 0.36 XU by D 1 minus 0.42 XU by D into FCK BW into D square plus 0.45 FCK into BF minus BW into DF into D minus 0.5 DF when the neutral axis lies outside the flange. Okay, next case is neutral axis lies outside the flange when XU is greater than DF, DF by D is greater than 0.2 and DF by XU is greater than 0.43. The equation that be above equation, that is case number 2 equation, is modified by substituting YF by DF. Instead of DF, you have to substitute the value of YF. YF nothing but 0.15 into XU plus 0.45 into DF. The value not greater than DF. So MU is equal to 0.36 XU by D 1 minus 0.42 into XU divided by D into FCK into BW into D square plus 0.45 FCK into BF minus BW into YF into D minus 0.5 YF. So in this case happen in the T-beam section, we have to use this formula to determine the moment of resistance of the section. Next is the computation of steel in T-beam. Case 1, normally we know this is a rectangular beam. As usual, we have to determine the AST by using this equation. Then case 2, when XU is greater than DF, dF by D is less than 0.2, dF by XU is less than greater than 0.43. We have to determine by using this relation. So equate the tension force is equal to compression, that is T1 is equal to C1. T1 we have to find out by using this one, ASTW into 0.87 Fi is equal to 0.36 FCK into BW into XU. From that we have to find out the area of steel for web, that will be is equal to 0.36 FCK BW into XU divided by 0.87 Fi. Then equate the forces in tension, T2 is equal to C2. So A, that is flange, area of steel in flange into 0.87 Fi, that will be equal to 0.45 FCK into BF minus BW into DF. That area of flange steel is equal to, that is ASTF is equal to 0.45 FCK into BF minus BW into DF divided by 0.87 Fi. So total area in the T-beam, that will be equal to ASTW plus ASTF. So you have to write like AST is equal to ASTW is equal to, you have to add to these two values, that is 0.36 FCK BW into XU divided by 0.87 Fi plus 0.45 into FCK into BF minus BW into DF divided by 0.87 Fi. This is the area steel for the T-beam. So in case XU is greater than DF, DF by D is greater than 0.2, dF by XU is greater than 0.43, replace the value dF by YF. So YF is equal to 0.15 XU plus 0.65 dF. Thank you.